Hi everyone, and welcome to another exciting video about Metasploit payloads. We've seen in the past episodes that the payload uses very interesting obfuscation techniques and also a very neat way to find function addresses and load them dynamically. We've also analyzed the whole functionality and figured out what it does. The shellcode downloads a file from an HTTPS location and then executes it. An important thing to note is that we've performed these exercises having Windows Defender antivirus disabled. Let's see what happens if we turn a real-time protection on. This was the file that we analyzed. Look at that. If we just try to copy the file, Defender activates itself and detects the file as malicious. It will also delete the files soon. This happens because Metasploit payloads are very well known and Windows Defender has no problem detecting them. In this tutorial video, we'll see one way to work around this detection. But first, let's go back to the Kali virtual machine we used to generate the payload. If you remember the command that generated the executable file, so we will modify it to generate shellcode instead. -fc specifies that we want to generate shellcode in the form of a C string. We will then copy this shellcode to clipboard to have it available in the other virtual machine. And then we'll use this skeleton script to hide our activities from Defender. Okay, we will go through each of the instructions in this code in a minute. Let's update it with the full command that we used in the comment over here. Okay, so what do we have here? First, the most important piece, the shellcode. In a form of a string, each character represented by its hex code. And then we create a type definition for a pointer to a function that receives no arguments and returns void. Then allocate a memory address that will have read, write, and execute permissions, and we allocate that dynamically using virtual alloc. This is very important. Next, we verify if the function call was successful, and if it was, we copy the shellcode from the static variable into the address that was allocated. After that, we convert that address to a function pointer in order to be able to execute it. This is a classic and useful trick. So this line is very important because if we try to convert this shellcode variable directly to a function pointer and then execute it, it would fail. It would actually fail because this variable is stored in a non-executable memory address. Another trick that I wanted to share is the printf function call over here. This block has two roles. First, obviously, it will terminate the program if allocation was impossible, and second, it allows us to quickly find this place in the program if we want to debug it and see what happened. Okay, in order to compile it, we just need the CL compiler, no special parameters, the full command is here. Okay, for this I'm using Visual Studio 2019. Because before being able to use command prompt, we need to load the environment for VS 2019. The command I've used is this one here. After this, we have access to CL and a lot of other CLI tools. Let's see how to compile it. We have the file here. Okay. This should be successful. We have the executable file generated here. Notice there was no detection from Defender, which is still active. In order to see that the file works as expected, like in the previous videos, we will use FakeNet. We'll start FakeNet and expect to see the request to download and execute the payload. Let's run it. Great! We're now able to pass Defender, download the payload from this address, save it as an executable, and launch it. Although this technique is simple, it can be used to work around Defender AV by manually loading shellcode generated dynamically and obfuscated by Metasploit. This technique might probably at some point be patched, but it's an ongoing game. One could always modify or update the technique and become stealthy for a long while until Defender catches up. This is just one of the methods, and in another video we will see a very different technique that also bypasses Defender but involves running code injected inside other processes. There are even more other techniques, and you can take this as an exercise and play with other payloads yourself. I hope you enjoyed this video, and please make sure to practice this on your own virtual machine and play around with the interesting assembly tricks. A final thing to mention is that it is advised to do all the exercises with your virtual machine disconnected from the internet. This is because Defender most probably sends a lot of telemetry to its cloud engine, and at some point your samples are more likely to be discovered. There are a lot of other interesting resources online on the topic, very much worth checking out. Thank you for your time and see you in the next part. Cheers!